Hello everyone, my name is Shamanawat and I welcome all of you in part 2 of lecture number 3 of Modulus. So here we are going to solve a few more questions having a few more equations having more than 2 modulus terms. So let's get started. So I'm assuming that you have gone through part 1 and now you are in part 2. So in part 1 we have seen that how to represent the zeros of each term on the number line and then divide into segments and then solve for each segment and then understand which solution is valid and which solution is not valid. Now in this video I am going to make it little shorter for you. So that step number 1 you have to do same, which is finding the zeros for each term. So for 0 for this term is what? 2 minus x. 0 for this term. What will you put as the value of x so that this part will become 0? Yes. 0 of this term, how will you find it? Equal to 0. So x is equal to what? 2. So x is 2, x is equal to 2 is 0 for this term. Similarly here, this will be minus 5, right? Now what you need to do? Now tell me one thing, is minus 5 lesser compared to 2 or 2 is lesser compared to minus 5? Correct. Minus 5 is smaller. So I will have minus 5 here and 2 here. Okay, so I have these 3 segments. I am not using the number line here to explain because now we have been there, done that. So now we have to be little advanced and faster. So minus 5, so that means one segment I will have x is less than minus 5. The second segment I will have which is x is between minus 5 and 2, and the third segment here will have x is more than equal to 2. Okay, so when you get zeros, then you need to arrange them in increasing order, yeah, and then you can divide accordingly as many segments as possible. So there are 3 segments possible because you got 2 zeros here and then you do it. Now look at the equation. So step number 1 is clear, finding zeros, understanding the segments. Now step number 2, where we are going to take each segment and then solve for them. So if I take the first segment, here, now how will I solve? The first segment is what? X is less than minus 5. Now when I have this equation, the original equation, 2 minus x and x plus 5, that is equal to 7. Okay, in that case, if you look at this, if in that case x less than 5, so now you understand x less than minus 5, how will you take negative positive? What you do is take x, any value of x, let's say less than minus 5 minus 6. So for 2 minus x, this term, if I substitute x is equal to minus 6, am I going to get a positive number or negative number? Think about it. So you don't have to actually think of is it left hand side of 0 or right hand side of 0. You can get rid of that particular concept. Okay, but it was important for you to understand in part 1. So if you see x is less than minus 5, take any random value which is less than minus 5 and try substituting in each part, each term, and see whether they are giving negative or positive. Accordingly you can take sign. So if I take x is minus 6, so here x is minus 6, so you can say this is becoming negative, yeah, this is becoming positive. If you take minus 6, so 2 minus minus 6 is going to be plus 6, right? So this first term is becoming positive, and similarly the second term, if you take minus 6 here, this is going to be what? Negative. So you don't have to remember left and right, you can directly take some random value of x and identify. Well, it means if you remove the modular sign, the first term should be positive and the second term should be negative. Simplify this. So I got 2 minus x plus x, minus, the second term will be minus x minus 5 equal to 7. What do we get by doing so? I have minus 2x here and 2 and minus 5, that's going to be minus 3, minus 3 this side is going to be plus 3, 7 plus 3 is going to be 10, 7 plus 3 is 10. So x is equal to what? Minus 5. X is equal to minus 5. Now look at this. We are looking for x is less than minus 5. Here we got x equal to minus 5. Tell me one thing. Is minus 5, we got x is equal to minus 5. So we need to check with the range. So do you find this minus 5 less than a 5? Yeah, so try substituting in the given segment. X is equal to minus 5. So do you find minus 5 less than minus 5? No, it's not. So what will you say here? This is not a valid solution. Okay. Next, look at the second segment. What was the second segment here? Second segment is more than equal to minus 5 and less than 2. So let's see that. More than equal to minus 5 and less than 2. Now simplify for this. Yes, simplify for this. What you get? Tell me which term should be negative and which term should be positive. By now you guys should be expert in identifying that. Take any value which is between minus 5 and 2. Let's say 0. 0 is between minus 5 and 2. Between as in between in this range minus 5 and 2. In this range you have 0 also. So if I put 0 here, 2 minus 0 is positive and 0 plus 5 is also positive. That means for this range, if I remove the modulus sign, both will be positive. So I have 2 minus x plus 5 equal to 7. Now simplify this. This is cancelled. 2 plus 5 is what? 7 equal to 7. Here I don't have any value of x, but this is universal truth, isn't it? This is a universal truth. 7 is equal to 7, right? So here you got a valid solution. You got a valid solution. You got a valid solution. And what is that valid solution? The valid solution is any value you substitute in this segment, because you don't have x. So the answer is independent of x. That means any value you substitute in this segment, it will satisfy the given equation. Okay. So here the valid solution is, this is the valid solution. Yeah. Now let's look at the third segment. The third segment was x is more than equal to 2. That was the third segment, right? Now for third segment, let's see what do we have. We got 2 minus x plus 5 equal to 7. So here take any value which is more than 2. Let's say 3. Okay. So if I substitute 3 here, 2 minus 3 is going to be minus 1. That means this term has to be negative, and 3 plus 5 is 8. So this is positive. That means for this particular segment, for this particular range, if I take off the modulus sign, we are going to get first term negative, second term positive. So open, first term negative, so minus 2 plus x plus 5 equal to 7. Here you got 2x, and then here you have minus 2 plus 5 is what? Plus 3. Plus 3 to the other side, 7 minus, so it will become negative. So plus 3 will become minus 3. 7 minus 3 is what? 4. So x is equal to what? 2. You got x is equal to 2. X is equal to 2 in range when x is more than equal to 2. So are you finding this value of x fitting in this segment? Yes or no? Think about it. Is 2 falling in this segment which is more than equal to 2? It says equal to 2. So here also we got equal to 2. So it is definitely fitting in that range, right? So here this way will say this is giving you valid solution and the valid solution you are getting when you have x is equal to 2. Understand the difference in segment 3 conclusion and segment 2 conclusion. Segment 2 conclusion is you are finding 7 equal to 7, which is universal truth. That means any value which you substitute in this range is going to be true. It's going to satisfy the given equation. And here in that segment you got the value of x. So in that case you have to take this value of x. Are you understanding the difference? That's why I have taken this particular question. Okay. Now let's see next. So what is the final solution in that case? We are done with all three segments, right? So what is the final solution in that case? The final solution will be, the answer will be here, this range. In this range, any value which we substitute is going to satisfy. So I take this range as it is. X is more than equal to minus 5 and less than 2, right? And counting this solution also, which is equal to 2. So here I will add equal to 2 also. So this is your answer. This is your answer. Do you want to see that? Let me show you. Let me show you. 2 minus x plus 5 mod is equal to 7. This was the original equation. Now you pick any value which is between minus 5 and 2 and substitute in this and see whether that is giving you equal to 7 or not. Any random value. Let's say I take x is equal to 0. Substitute 0 and 0. So here it will be only mod of 2 is 2. Here you will have only mod of 5, which is 5. 2 plus 5 will get you 7. Left hand side equal to right hand side. Satisfies. Little complicated, little difficult value. Let's take a decimal value. For example, let me take x is equal to 1.5. 1.5 is between minus 5 and 2, right? So x is equal to x is equal to 1.5. So 2 minus 1.5 is 0.5. Yeah. And 1.5 plus 5 is 6.5. Add both of them. You again get equal to 7. So do you believe now? Do you believe now that this range is the solution? Yes. That's why I told you at the beginning of part 1 of lecture number 3 that whatever we have learned in lecture number 2, that will always be applicable when you solve any modulus equation having one modulus term. But when you have more than that, when you have multiple modulus term, follow this segment method. That will get you the solution. Yeah. In the competitive exam for which you are preparing, they are very smart. So they are going to give you a tricky equations. They are not looking for human calculators. They are looking for people who can apply the concept logically and get the solution. Problem solving skills, right? Okay, one more. Now you have learned enough. You can pause this video and try attempting this question. You can try this out. Next question. Now here you got three modulus terms. So how will you simplify this? Same way. Take zeros. So here you will have 0 at minus 4. Here it will be 0 at 0 and here it will be 0 at plus 3. Wow, they are already arranged in the ascending order, right? So now you have got 4 segments. See, minus 4, 0 and 3. So you got first segment here, which is less than minus 4. The second segment will be, let me write it like with a white ink. Oh, what am I removing? Yeah, let me use a different ink. Minus 4, and this will be x more than equal to minus 4 and less than 0, and here x more than equal to 0, less than 3, and here it will be more than 3, more than equal to 3. Yes. When I go to the next segment, I take equal sign. Yeah? You can see here for 3 we don't have equal in this segment, in the third segment. 1, 2, 3, 4. Yeah. Okay, so let's simplify this. Now here, let's try for the segment 1. We have 4 segment, so let's solve a little faster. First segment, -4. Now -4 less than -4. Let me write this: x plus 4 minus x minus x minus 3 equal to 3. So less than -4, this will be negative, this will be negative. Why is it looking like n? This is x. Okay, and this will also be negative, less than -4. You can assume, you can take x is equal to -5 and try with all of them. Less than -4, any value less than -4, and try with all of them. Yeah, so remove the modulus sign, so that should be the condition. So you have got minus x minus 4, minus minus will be plus, minus minus is plus, equal to 3. Now simplify, you got x cancel, so you have got only single x here, and minus 4 minus 3 is minus 7, minus 7 to the other side. I will get x is equal to 3 plus 7, that's going to be 10. Yeah. Question: x equal to 10 for segment 1, which is x is less than -4. So do you have x equal to 10? Did you get the value of x which is falling in this range? No. So what do we say in that case? Not a valid solution. Are you learning? Are you understanding? Yeah, I know part 1 was little lengthy, complicated, but I had to make you understand zeros, what is segment 1, so it was important to understand. And as I said, as and when we keep going towards finishing this course, I will keep on showing more shortcuts. Second segment, which is between -4 to 0. In that case, the first part will be positive, second part will be negative, and third part will be negative as well. Yeah. So first part is positive, second part is negative, and third term is also negative as well. So can I write the term directly without writing the question again? Yeah. So first part is positive, that means x plus 4 will be the positive. If you remove the modulus sign in that range, it will be x plus 4 and negative. So negative and this negative will become positive again. This negative and this negative will become positive again. That's the condition, equal to 3 here. So what do you get? X is 3x. 4 minus 3 is what? Plus 1. Plus 1 to the other side will become minus 1. 2 minus 1 is what? Sorry, 3 minus 1 is what? 2. So x is equal to 2 by 3. Do you find this 2 by 3 in the range of -4 to 0? Tell me, do you find that? No, that's not. So what do you say in that case? This is also not a valid solution. Yeah, so when I say negative, see, you have to this term inside the modulus, when you remove that, that will become negative. So this negative sign will be here. So negative and this negative. So minus of minus x will become plus x. That's how it is plus. And same for this also. Minus and minus will become plus. That's how this is plus. Yeah, and because the outside sign is plus, the inside sign will not change. Understood? Okay. Now let's see the third segment. The third segment is, we got 4 segments. God, let's go faster. More than equal to 0 and less than 3. Third segment. In third segment, let me write this for you. The question is x minus No, I did a mistake in the solving the second one. Okay, x plus 4 ही था वो. हाँ, no, correct. All good. X plus 4 ही. Okay. So x plus 4 minus mod of x minus x minus 3 equal to 3. So here in this range, if you take any value, let's say 1. So this is positive. Substitute 1 here, this will be positive. Substitute 1 here, this will be negative. So when you take off the modulus sign, x plus 4 will be as it is. This will be minus x. This will be minus plus x minus 3 as it is equal to 3. Right? So you got 4 and 3, which is 1 again. 1 plus 1 towards the other side become 2. Here 1x is gone. So here only x will have, and that's equal to 2. So x is equal to 2. Is this part of this segment? Of course. 2 is between 0 and 3. So here we'll say what? This is a valid solution. Look at the fourth segment quickly. Segment 4, which is what? More than equal to 3. In that case, you will find all the terms positive. X plus 4. Take any value of x which is more than 3, and you will find all values which are positive. All the terms will be positive. Okay, so x plus 4 will be as it is. Open the bracket. Plus into minus will remain minus, so negative x. Same for the third term also, minus of x plus 3 equal to 3. What will happen here? X cancel. Plus 4 plus 3 will be 7, plus 7 will go towards the other side. 3 minus 7 will be minus 4. Yes, and minus x as it is. So this minus x as it is. So negative cancel here. You will get x is equal to what? 4. Now question, are you getting value of x which is falling in this segment, in this range? Answer is yes. X is equal to 4 is more than 3. So this is also a valid solution. This is also a valid solution, right? So you got now only 4 segments for there. We solved for all 4 segments and we got 2 valid solutions. One is x is equal to 2 and one is x is equal to 4. So what will be answer? Tell me, what is the answer? You get x is equal to 2 or 4 for both of them. Both of these values will satisfy the original given equation. That's the answer. Yeah. Now when you are going to solve objective exam, you have the options given there. Things will be much easier because you can use the options to find the right answer. You can directly substitute the options, right? So we will have those kind of questions also, you having the options with them. So are you understanding? Did you understand how to solve these equation having modulus term, more than one modulus term, multiple modulus term? Yes? Okay. So in next lecture, we are going to discuss graphical representation of modulus equations having 2 variables x and y. So this is it in today's lecture, this video. That's the thing. This is the end. My name is Shah Manavat signing off. I will see you in the next lecture where we are going to solve, where we are going to see how to graphically represent the modulus terms. So till then, stay happy, stay healthy. Bye bye.